For section 2.4, part 2, we are going to be working on area of a surface of revolution, which really all that means is that we're going to be working on surface area of an object that's circular. So, as you can see here, what we found before is we have been able to, with the last equation, been able to find the length of this line. Now, we want to know what happens when we take that line and revolve it around the x-axis. So, first of all, I want you to kind of think of, find a place here to write, think of like a cylinder. So let's say this is an oatmeal, a can of oatmeal, okay, laying down. All right, and I want to know what the surface area of this oatmeal is. Well, before, when we would take, and we don't want to know the ends, so this is not including the top and bottom. They're open-ended, okay? So before, when we would find the net, we would cut that oatmeal can and roll it out, right? So kind of like we were talking about with our shell method, except our shell method went around the y-axis. This is going to be going around the x-axis, and it's not filled in. So our shell method, just remember our shell method is to find volume. This is a surface area. All right, so when we roll this oatmeal can out, then what we have here, also notice that the x-axis is going through the center of our can, and the height of this can is going to be whatever our function value is. So if we had y equals 4, then 4 would be the radius of our can. But it's going to be whatever that function, the height of that function value is. And we get the height from the y value or the f of x value. So the height or radius of the end of our can is now f of x, because we're going around the x-axis, not around the y. So I don't want you guys to get confused. I just want to make sure you know that when you're doing the shell method, we're going to use 2 pi x because we're using that diameter of a circle still, but we're going around that y-axis. This time we're going around the x-axis. So when we look at the diameter of the end of the circle, or the length when we roll that out, now we have 2 pi f of x as the height. So that's going to be the main difference between the shell method and this area of surface revolution. So that height is going to change depending on where in the equation you're at. So we just use f of x for that. And then when we rotate it, we have 2 pi times f of x. Now on your can here, we would have the length. We would need to know what the length of this side is. Now on a straight can, it would just be x. However, when we have this curved line, what would be the length of that line? Well, it's not just going to be x, because there's a lot more to it, but remember that we just proved that we could find the length of this line with the equation 1 plus f prime of x squared. Take the square root of it and integrate it from 0 to a, and that's how we find the length of that line. Alright, so hopefully you can see now about where we're getting at here. So to find the surface area of a revolution, we are going to take the integral of, because we have, this is our layout right here, so we need to take the circumference of our circle at any given point. So remember, our circumference we said was 2 pi times f of x, and then times the length of the line that's being circulated around the x-axis. So from here, from our curved line, this is what we get. So we can multiply that integral, we already said we're taking the integral, so we can just multiply it right on, of 1 plus f prime of x all squared. We'll just, and dx. And then that's our new formula from a to b. And here it is written a little bit nicer. So surface area of a surface of revolution, and your equation is the integral from a to b of 2 pi f of x times the square root of 1 plus f prime of x squared. You just crawl on the floor. I can't see the floor. And then down here, this is if you were going to revolve it around the y-axis. It would be just in terms of y instead of in terms of f. All right, for example number 1, we need to find the surface area of the revolution of about the x-axis of y equals 6x plus 2. So let's draw what our equation is going to look like. 6x plus 2, I'm just going to estimate it here. It's going to go through the y-axis about here and have a pretty steep slope. Now if we revolve that around the x-axis, going to reflect it down here, and then we'll have this revolution. Now we are going from 2 to 3. Is where our points will be from. So we're going to get this hollow cone looking shaped object. And we want to find the surface area of that. So we could use our equation. So the surface area is equal to the integral from a to b, which in this case is going to be from 2 to 3, of 2 pi f of x, which is 6x plus 2. And so if we were going to cut the edge of this shape and roll it out, it would have an end length of the circumference, which is 2 pi times 6x plus 2. So the reason that we have used the function there is because you notice your circumference is going to change every single time depending on where x value is. And that's exactly the whole purpose of the integral. It is to take the sum of every single different x value. Then times the square root of 1 plus f prime of x. So we need to write up y prime here. So y prime is just going to be 6. So 6 squared. And then include our dx. Alright, so let's rewrite that. We can have 2 pi here. And then integral from 2 to 3. And then 6x plus 2. That's going to give us the square root of 37. That square root of 37 can actually be pulled out also. So we get the square root of 37 pi times the integral from 2 to 3 of 6x plus 2 dx. Now we can go ahead and integrate. And we'll have 6 over 2 x squared plus 2x. And then integrate, evaluated from 2 to 3. Okay. And then put in, so we've got 3x squared plus 2x. Come over here to evaluate. 2 square root of 37 pi times 3, and then plug in our 3 squared plus 2 times 3, and then minus what we get when we plug in the, oh, we already have that written, we don't need to write that again. Just right here, then minus what we get when we plug in the 2. Subtract it all. Alright, so for my answer on that one, I just plugged it into my calculator from there, and you should end up with 649.7. Uh-oh, I can't read my handwriting. I think it's a 7525, but something right around those lines. And that is our example number 1.